Hello, my adoring fans. Great to see you. Oh, you think I can't? Okay, so we are going to look at standard C right here, 8C, which is all about acids and bases. So right here it says describe observable properties of acids and bases. That's one part of it. Draw models indicating how they interact with hydrogen ions. All right. So yeah, let's just get right into it. Let's talk about properties. All right. I guess we can do acids first. So acid properties here. The biggest one, the defining one, is that they donate or lose hydrogen ions. Some other big ones, they turn litmus red. There's some they have in common. Let's just do ones in common too. Ones they all have in common is that they're corrosive. Let's see, what's one for acids? They're sour. They taste sour generally. Whereas bases taste bitter. Which again, the major one for bases would be that they absorb or take up hydrogen ions. What are some other big ones? Let's see, they both conduct electricity because they're always producing ions in solution. So that's for both of them. A lot of times bases have OH minus, but they don't have to, just most of the time. I should really change this most of the time. Let's see, what else? Acids and see, a good place to look for this is in the reading, which let's find it. It is on page, oh, there we go, page 16. Alright. Oh, how they feel, right? Bases feel slippery. That's a good one. Bitter taste, did that, slippery. Oh, they're both toxic. That has to do with the corrosive slash toxic, right? If you eat something that chemically eats away at things, it's not going to feel good. They respond to indicators. Acids can dissolve metal. That's just corrosive, same idea. Okay, I think that's the big ones for the just general properties there. Let's do the draw model and just go back to some other properties, because we're going to talk about pH, but it's not going to make a whole lot of sense until we've seen models of it, I suppose. Okay, so let's draw what an acid would look like. Let's do an acid, just a simple one like HCl. Okay, so if you put some HCl in water, HCl is a strong acid, dissociates completely, so you're just going to have H pluses, and then what's left over, Cl minus. It's minus because, if you have a plus, and minus has to cancel for it to be overall. There's no charge here, right? So just have a bunch of H pluses, Cl minuses, just H plus, all that stuff. You get the idea. It's homogeneous, it's evenly mixed, it's completely dissociated here. Now, like I alluded to, this is a strong acid, which all that means that it is completely dissociated. It's completely broken apart. Whereas, let's take a weak acid. What would be a weak acid? Well, this is a weak acid. This is what happens when you take the strong acid, H2SO4, and you give away one of its hydrogens. You get this guy, which is still acidic, but very weakly so. So if you put this in water, it's still going to give away some H+, so now we have SO4, but it's going to be 2 minus, because it was already 1 minus. You're going to have some of those, but most of it is still going to be the combined version. So it's only partially dissociated. So partially, and this is a weak acid, partially dissociated. Right? Whereas the strong acid is completely dissociated. And it's going to be the same thing for weak and strong bases. They're going to partially dissociate and completely dissociate. So for something like NH3, which is a weak base, in water, you're going to have mostly NH3, but then you're going to have some NH4 plus, because it's gained an H plus, and it takes it away from water, so from the water you're going to have OH minus left over, because if you think about it, it's from H2O. If you take away an H, you're left with OH minus. I don't know why they put the O first, but then they put the H first here. It's kind of confusing, but that's how they do it. That's how you're always going to see it, so that's how I'm going to do it too, so you're not confused when you see a chemistry class later in college or something like that. Okay, last thing, let's talk about pH. So pH is a scale that is oftentimes used to easily measure how strong or weak an acid or base is. 7 would be neutral. It goes all the way to, people say 1 or 0, whatever. This would be the acid size, so if it's less than 7, it's an acid. Now, if it's like 6.9, people are like, it's neutral. But I've never seen an official cutoff anywhere, so if it's less than 7, then technically it's acidic, but I mean, come on. So 6.5, on a test, hey, say technically that's an acid. The further you go here, say maybe 3 to 4. If you're over here, this would be, I would say, strong. If it's low enough, 2, 1, 0, 0 is definitely a strong acid. This would be a weak acid. Goes up to 14, and again, kind of halfway in between here, 9 or 10, I don't know. Call this a weak acid, or a weak base. Right, this is the base side, all about that base. This would be a strong base, so more dissociation, whereas weak is less dissociation. Right, they're not as good at giving away H plus if you're an acid, or at taking H plus if you're a base. I think that's all I don't know what else there is. We talked about some of the safety precautions you have to take because it's corrosive. Like, you always wear goggles, gloves. If it's a really weak acid or it's not very concentrated, sometimes it's not a worry. It's not an issue. Yeah. So do the homework, do the readings, and you should be fine. All right. Come to office hours if you're confused, and I'd be happy to help you. Bye-bye.